Hello everyone, my name is Shubhayan Sengupta and I'm here to teach you a topic on class 9 ICSE Computer Science. And if you like my video, please subscribe. So we will start today. Today my topic is Introduction to Object-Oriented Programming. So you will be learning Java language in class 9. And we have to first understand what is object-oriented programming, what is that concept, and why do we need object-oriented programming. So I'll straight away start. So the topics today we will cover is why use OOP or object-oriented programming. What is object-oriented programming? Then the four basic pillars or the four basic concepts based on which this object-oriented programming is based on, or Java language is based on, or any object-oriented programming is based on. What are the building blocks of object-oriented programming? Classes and objects. We'll just briefly touch it. We will not go into details of it. Then what are the advantages and disadvantages of OOP? And finally the conclusion, a wrap up of all the topics that we have covered. So if we see, we have to first understand before going into object-oriented programming, why do we need object-oriented programming, or why it has become so popular, why it is so important for programmers to use object-oriented programming. So object-oriented programming, or OOP, is one of the most widely used programming paradigm. Now what is paradigm, you must be wondering. Paradigm is a way of thinking. Paradigm is a kind of way to solve a problem. Now before we go into OOP, we have to first understand what was the paradigm before this, and that's how we will understand why this OOP has grown so popular, has become so popular. Initially when computers began, we had assembly language, then machine language, and different kinds of languages which were very difficult to program, because we are not used to 1, 1 and 0, 0. Because computers understand only 1, 1, 0, 0, binary language. So it's not very easy for human beings to programming in this. So later on, programs or languages like COBOL, Fortran came up, which were called procedural programs. Now, what do we mean by procedural program? In a procedural program, we write set of instructions. There are just set of instructions which tells the computer what to do. The computer executes those instructions and gives the result. Now the focus on those procedural programming is on the procedure itself. How do we solve the problem rather than the data? Now data is the most important part, because that's the part we are working on, not the procedures. So Fortran, COBOL being procedural programs, they had methods, they had functions, they had methods, say add, and they used to have parameters over here, and a program block would work on this data that is passed as parameter or argument and give the result back. So there would be a return from this functions. But the main function, importance or focus was given on these methods like add. If you have a calculator, you will have to have the add method, the subtract method. So most of the procedural programs focused on what would be the methods, what would be the algorithms, rather than the data that is coming in. And that's why it led to the problem that complex problems, complex situations, like if you have an airline reservation system, how will we solve that using procedural programs. It was very difficult because we couldn't model the real world objects. We couldn't really find out a solution to the real world objects that we have. Now, what are objects? See, objects are anything that is around us, the table, the chair, the fan, the light, everything is an object because each of them has certain characteristics and each one of them will behave in a certain way when you do something. Suppose if there is a light, we consider that as an object. So, attribute of it will be how much brightness it gives or wattage. So, we have 60 watts or 5 watts or whatever. So, that would be one of the characteristic or attribute of that bulb, and behavior is when we switch on, the light will come on, the light will glow, it will give the light. So, that kind of mapping from the real world to the computer world or the digital world was difficult with procedural programming. So, the procedural paradigm shifted from procedures to object-oriented programming, where you could model the real world objects, actual real world objects into the computer or the digital world. Okay, so we have just briefly understood what is object-oriented programming. We'll go into this detail later. Let me just okay. I'll just try to remove those later. Now, why is it extensively used? As I said, it is well suited for building trivial and complex applications. So, from small applications like simple programs, desktop applications like calculators, to very complex applications like airline reservation systems or railway reservation systems can be done using object-oriented programming. Allows reuse of code, thereby increasing productivity. Now, what do you mean by reuse of code? Well, if you write a part of the program for, say, airline reservation system, that part of the code or that block of function can be reused in another program, or we will see later where through inheritance, where from a parent object, the child object actually receives some of the methods, some of the attributes. So, you don't have to write again the same attributes or same code for the child classes. So, we will go into that later. Now, new features can be easily built into the existing code. So, if you have something, say if you have a car, that's a generic object, a car, and I have a specific car, say Mercedes Benz. So, I will be adding from the car, I will be inheriting, which we will see later, we will be inheriting another object, another class, which will have the particular attributes or the behaviors of Mercedes Benz. So, I will have to just put the code for or the new features for Mercedes Benz rather than writing entirely the class of car again. And it has reduced production cost and maintenance cost. So, what is production cost? Production cost is the cost of developing the program, developing the entire application. So, if I have pieces of code which I can reuse, then of course the production cost will come down, and maintenance cost is the cost which will incur if I have to make some enhancements or if I have to make some additional features, add some additional features to the application. So, that is also easy, as we said earlier. So, the maintenance cost also will come down. Okay, now what are the common programming languages used for Root? This includes C++, Java and C#. So, Java you will be learning in class 9, which is totally object-oriented programming language. C++ and C# are object-based programming languages because it doesn't have certain features, and we cannot say it's a completely object-oriented programming language. Okay. So we will go into the next slide. Okay. Okay, what are the building blocks of object-oriented programming? The building blocks of object-oriented programming are mainly the objects itself, or the model of the real world object, example as it is says over here, computer, book, box. So these are all objects in the real world, and how we are modeling it into the computer world or into the digital world. Object could be a concept like meeting and interview, which is not tangible. You cannot touch a meeting or you cannot touch an interview, but that also can be considered as an object because it will have some characteristics, certain behaviors. It could be a certain process, example sorting a stack of papers or comparing two computers to measure their performance. So it could be a process which we try to model into the digital world or make an object of that in the digital world. So object, we will see in details what is an object in Java or in an object-oriented programming language. Now, before we can create objects, actually we need to have classes. Now, what is a class? Class is a prototype or blueprint from which objects are created. So class is actually the basic design of the object that we are trying to model. So class will have the source code, or class you have to write in a program so that the basic design or the structure of the object is captured in that class. So it's part of the source code actually. Class you have to consider it as part of the source code. So class is a prototype or blueprint. It's actually a blueprint. You must be knowing what's a blueprint. Blueprint is kind of a high level design of the building plans that we make. The design is made in blue ink, so you'll have, that's why it's called a blueprint. You'll have the details of the building or the flat that you're looking at, and these are made by architectures. So that's why it's called a blueprint, and similarly, class can be called as a blueprint from which objects are created. So we have a class, we have the design, and from there we will be creating objects which will contain that design inside them. So we'll come into the details of this later. Okay, so if we continue, we go into further details of class. So a class has set of attributes or properties that describes every object. So as I said, every object will have some certain attributes or characteristics, and that we'll have to put in the class, that we'll have to write in the class which kind of attributes or characteristics we are looking at. For example, a car, if we take an example of a car will have a color. So that's a characteristic, that's an attribute of the car. It will have shape. Shapes of cars are not same all the time. So it will have different shapes. So that's another characteristic. So similarly, we'll have different kinds of attributes or properties that describes that object, particular object in the real world. So we'll have that in the class, and a set of behavior or actions that every object can perform. Now, what is a behavior or action? For example, a car, if you have a car object, a car behavior, one of the behaviors would be starting the car. It's there standing still. You put on the ignition key and the car starts. So that's one of the behavior. The car engine starts. Then another behavior could be you accelerate. So you start from 0 kilometers per hour and then you slowly accelerate and move the car, and it goes on increasing, the speed goes on increasing. So that's another behavior or action of the object, of the car object. So that behavior or actions also has to be part of the class, because if we have to accelerate a car, then that behavior, or we'll come to that, a method which will come, which details I'll go into later, that method has to be in there in the class. Okay, and what is an object? Okay, the object will have set of data or value for each of its attribute. Now, an object is actually a specific version, or should I say a specific instance of that class. So when I create a class, there is no memory allocation, which I'll come into later. When I create a class, it has no memory allocation, it's just as part of a source code. But when I create an object, at that point of time, actually memory is allocated, and all the attributes and the behaviors that we had written in the class is actually copied into the memory. And each object, for example, Mercedes-Benz was a specific type of object of class car. We can have another object, say Ford Mustang, that will be another specific, that will have another specific set of characteristics, but the values will differ. For example, a car color, the name color will be same. So color of the Mercedes-Benz could be blue and color of the Ford Mustang could be yellow, but that color characteristic is same. So the Mercedes-Benz object will have color as blue characteristic, so it will have a specific value for the Mercedes-Benz object, and for the Ford Mustang it will have a yellow color. So set of data or a value for each of its attributes, a specific set of values for each of its attributes, a set of actions that it can perform. So as I said, you will have behaviors like start a car or accelerate a car. So that will also be there inside the object. That has to be there in the object, because otherwise it doesn't make sense only having the set of attributes or characteristics and not having any methods. If you don't have the methods, you won't be able to make use of those attributes. So each object will also have a set of actions that it can perform and an identity. So when I'm creating an object, I'll have to give it a specific name, whether it is Mercedes-Benz or it is a Ford Mustang. So each object will have an unique identity or unique name. Okay, and each object belongs to a class. So without a class, you can't really create an object. So each object has to have a class, has to have that blueprint from which that object is created. So we'll go into this details soon. Now, here we see it, as I was saying, the examples. Here we see a real world example of objects and classes. So over here, I have the class called Ford car. Okay. This class Ford car is a generic class or a blueprint for all Ford cars, all type of Ford model cars. So it has attributes like color, type, model, cylinder. So these are you can consider these as containers, container for the characteristics, containers for the attributes of that Ford car. So each Ford car will have a color, each Ford car will have a type, a model, a cylinder, or the engine size. And what behavior we are looking at? Behavior, as I said, start, accelerate, reverse, stop. So these are some of the behaviors a Ford car will show. So these behaviors will be there. Now, this class, when I create an object of this specific class, I create an object called Ford car 1. Now, each of these attributes are copied into memory, as I said. These are part of this objects now: color, type, model, cylinder. So these are all the attributes that are part of the objects now. But each one of them has a specific value now. So when I created the object Ford car 1, I said the color of the Ford car would be yellow, the type would be coupe, model will be Mustang, and the number of cylinders will be 6. So that's the engine size basically. So this would be quite a big engine, 6-cylinder engine. And the behaviors also will be copied: start, accelerate, reverse, stop. So these would be the methods which will come later, which we'll go into later. But these are the methods that will work on this attributes over here. Okay. Then we have another object. We create a second object from class. It has the same attributes, but now the values have changed. So Ford car 2 will have color orange, type is same, coupe, but the model has changed, focus, and the cylinders are 4. So it's a smaller size engine. So the cylinder size has changed, but the attribute or the characteristic cylinder remains the same because that's part of the blueprint. Only this object has a different value for it. Okay, so we have created two objects from class. We'll go into this later, how to create an object from a class, or how to write a class first and then in a program how to create the objects. Okay, this is a real world example of objects and classes that we were describing. Okay, this is another real world example. For example, we can have a class as a person. We have a person class, attributes, each person will have a name, each person will have its height, its age, we can add gender. So each person, if we consider in the real world, will have this kind of characteristics. So we can model it over here in this class. So person, he or she will have a name, height, age, and gender. And what would be the behavior? He can speak, he, she can, or she can speak, listen, eat, run, walk. So these are some of the behaviors that a person shows. These are some of the actions that a person can take place in a person. So we create a specific object for that, person 1. So I create an object called person 1 and we give it specific value. So name is Anne, height is 5 feet 4 inches, age 21, and if it was if we had the gender characteristic, maybe it would be a female. So we have that attributes or characteristics over here, the specific values given to it. We have the behavior over here, that is part of the object now, speak, listen, eat, run, walk. And we have another object called person 2. And this also has the same characteristics, but the values are different, as you can see. So we have Adam, whose height is 5 feet 9 inches, age is 24, and gender, if we add, it will be a male. But the behavior is same because each person will behave the same way, speak, listen, eat, run, walk. So this is another real world example of an objects. We'll go into the next slide. Okay, so we come back to what is a class. So class is a set of variables to represent its attributes. So you must have in your earlier classes must have done some programming in BASIC where you must have learnt variables. So variable is nothing but a container or a specific type of container where you can store some values like a number or a string. So a class will have a set of these kind of variables to represent that attribute, to represent the specific attributes. For example, we saw the attribute of say in the person class, name, height, and age. So that those specific attributes will be stored in the class as set of variables and functions or methods to describe its behavior. So as we saw in the person, speak, run, walk, eat. So these are the methods or the functions to describe the behavior. And these behaviors or these functions will work on these variables, will act on its variables to change the values, to show what is the current state of that object by changing the values of the attributes, of the function, of the characteristics. Okay, so that's a class. Now consider, if you consider a shipping box, we saw the example of car, a person. Now if you consider a real world shipping box, you are trying to gift wrap say some gift and send it to your friend who is in another country maybe. So in a real world example, what will you do? You'll have a shipping box prepared to put that gift wrapped object into it, and on the shipping box, before you send it to the post, send it by post, you will be having the sender name. Sender name means from where you are sending it. So you'll have your name over here, sender name, string. Now string will come later, but this is a type of variable. This is the type of variable, and this is the variable name, sender name. Receiver name. So who is going to receive it? What's your friend's name? That we will be putting it. So this is another variable. Now what is the cost per pound? So what is actually per pound cost of that shipping box? So this is a kind of a number you will have. What is actually the weight of that shipping box that you're sending? So that will be also a number, an integer type variable. So these are all integer types variable, and these are string type variables. Okay, so we have different variables, and we can have a behavior or a method. This is a method with this brackets over here, close, open and close parenthesis. So these are called methods, and this is the method name, shipping cost. So basically it will calculate the cost of the gift box, shipping box, and return it back to you. So the shipping cost is the method, and it will return, it will act on these two variables, cost per pound and weight, and it will return that value back to you. So this is the behavior or the function that is there in the shipping box class. So we will have, from a real world, we have mapped it down to the digital world. So this is my sender name, receiver name, cost per pound, weight. So these are all the attributes or the characteristics, and this is the behavior, and it will work on these two variables. As I said, these are variables, so this will work on these two variables and return the actual cost of shipping to you. Okay, so that's the mapping of or portraying. Okay, so we will have actually say if the cost per pound is say 5 pounds and weight is say 2 kg. So in real world we'll be calculating $5 into 2 kg, so that will be $10. So this value, cost per pound into weight, will actually be calculated in this method, and this will get returned back to you. So you'll have the shipping cost method returning the cost of shipping the box as $10. Okay, so this is the mapping of the real world shipping box to the digital world. Now we will go into the next slide. We now see what is an object. Now object is an instance of a class that holds data or values in its variables. Now data can be accessed by its functions. Now as I said, when you are creating a class, it doesn't have any memory allocation. Now what do I mean by memory allocation? See, each application which you make, actually has to be imported into the memory area before it starts executing, because without getting it into the memory, CPU won't be able to execute the instructions that are there. So if I have a memory block, say this is a memory block I have, then when I create an object or I create an instance of a class, it will hold the data values. So in this shipping box example, as we saw, the sender name, I'm just putting S name over here, the sender name or the receiver name, that will have a memory allocation. So each one of them, each one of these variables actually has a memory allocated to it. So a string type will have a certain memory allocated to it. So sname was a string type. So this will have a certain amount of memory space allocated for it. The receiver name will have it. Then we can have the weight. So that's an integer type. So that will have memory allocated to it, and specific values you can then assign. So sender name you can have as Joe, you can have as Anne, and weight you can have as say 2 kg. Okay, so you can have specific values stored in the data, stored in the variables. So you're telling that this object will have the sender name as Joe, will have receiver name as Anne, will have weight as 2 kg. So I can call this as object 1. So I have created an instance of the class that has got some memory allocation. We have certain values, specific values for those variables, and the method shipping cost, I'm just writing SC over here. Shipping cost method will actually work on weight and the cost per unit pound. So shipping method will act on this weight variable and the cost per pound method, cost per pound variable, to calculate the total cost of the shipping box. Okay, so we are now actually creating the memory allocation. We are trying to run the application. So this values will be there at runtime. So the application has started executing, and over there it will have some specific values. The variables will have some specific values, and the methods will act on these variables to give you the actual cost of the specific object. So I can have another shipping object. I can create another object ob2, and I can say sname as say Anita. I can have receiver name as say Mary. I can have weight as 1 kg. I can have cost per pound. So cost per pound equals to $3, and then I'll have the method or shipping cost method. So over here again we have specific values for the different variables. So we have Anita as sender name, Mary as the receiver name, weight as 1 kg, cost per pound as $3, and then the method will work on this weight and the cost per pound and will return you $3 because weight was 1 kg, cost per pound is $3, so 3 into 1, $3. So this value will be returned back to you. So object 1 has different kind of values, object 2 has different kind of values, though the variable names are same and the method is same, but method working on this variables returns a different value. If suppose I don't have the cost per pound over here, if cost per pound was say $4 over here, then this method will return me $8. So I'll have 2 into 4, $8 returned back by the shipping cost method. Okay. So object is an instance of a class. We have the class as a blueprint. Now we have it in the memory at runtime. We can assign specific values to these variables, and the methods actually starts executing their instructions to return return certain values depending on what you want the method to do. Okay, so we'll go into the next slide. So as I said, as I gave an example, so this you can see over here. So we have actual objects of shipping box class, object box A, object box B. Each one of them has different values, and the shipping cost method then returns the actual value back to you. So as I explained in the earlier slide, the same thing has been given over here just to make it more clear. Okay, we will go into the next slide. Now we saw part of why use OOP, what is the building block of OOP. Now we go into little details. We see what is object-oriented programming, or what is actually behind, what is actually going on behind object-oriented programming. So as I said, OOP is a paradigm for problem solving by interaction among objects. So what do we mean by this? That this means that in the real world actually what happens is, if you have say a person 1 and you have a car, so these two would be different objects in the real world. So you have a person and you have a car. You have a car. So this person object wants to interact with this car. How will it do in the real world? He'll most probably walk up to this car, open the door and start the ignition key. So that's how in the real world the operation is done, or two objects interact. Now in the digital world also we can have different objects like this, and there will be interaction among these objects. Now, so these objects as which I am talking about are for different classes. So even in the same class, if you have different objects, if you want to interact between them, you can do that also. And it follows a natural way of solving problems. So as we do it in the real world, person is here, he walks up to the car, opens the door, starts the car, and the car starts moving. So in a similar way we can do it in the digital world by using OOP. So it has a natural way of solving problems. We are just modeling the real world problems, real world examples into the computer world. So for example, as I said, I have a person, say Anita is the person, she wants to start her car. So what will she do? She walks up to the car, and over here in the computer world, how can two objects interact? By sending messages. So message is nothing but a kind of data that you pass on to the next object, saying that okay, object say car object over here, you start the ignition, you do the ignition thing, or you call the start method and it turns on the ignition key. So you have to pass a message from this person object to the car object. So that's how two objects interact between themselves. So Anita sends a message to the car to start by turning on the ignition, and the car starts. So this turning on the ignition, how will it do on the car object? There will be a method over here, the start method, and a message will be passed to the start method by the person object, and that message will be interpreted by the start method and it will start the ignition key. So the car starts. Okay, now we'll go into little more details of this. So if you see it diagrammatically or graphically, what is the problem? Anne wants to start her car. How will she do it? Well, we have an object of Anne over here. We have the attributes and everything, the behaviors. Now this Anne object sends a message. As I was saying, objects of different kinds or similar kinds can interact by passing messages. That's how the object-oriented programming is based on. That's the pillar that is based, how interaction is done in object-oriented programming. So it passes a message to the object of Anne's car. It has certain characteristics, behaviors, and it receives the message, and the message actually goes to start method or the start behavior. So this Anne object will call the specific behavior of this Anne's car to start the car, and it passes a message to this method, to this behavior. Okay, so that's how problem solving is done in object-oriented programming. Now there is another example, or this is another principle on which object-oriented programming is based on, which I will go into details later, but just to see it at a high level. So if we have a bank account, that could be a checking account, or checking account means your current account, and a savings account. Now in inheritance, what happens is you have this parent class. Say bank account is your parent class, and your savings account and your current account becomes your child classes. So you have a kind of parent-child relationship. So this bank account over here is the parent, and you have child classes, say savings account or your checking account. So these are actually inheriting from the bank account. So you will have these three attributes coming into the checking account, coming into the savings account. That means these child classes or child objects receives this attributes of behaviors, and in checking account you can have an additional characteristic or attribute, say insufficient funds, or over here for example you can have this interest rate in the savings account. So these are, since these are child accounts, child objects, they are adding their own behaviors or own characteristics. Similarly, you can see in the behaviors, as I said. So you have in a banking account, normally we'll have deposit and withdrawal, but in a checking account we have these two behaviors, and in addition we have the process deposit. In this we have the calculate interest. So each child object adds its own specific attributes or methods to this parent class. Okay, so we'll go into this detail a little later. Okay, this is gone bad. I don't know how this happened. Anyway, we'll go into this abstraction. So abstraction means extracting the essential properties and behavior of an entity. So for example, when you have the car object, when I started the ignition key, I am not aware what is actually going behind in the hood. I just know I have to start the ignition key, turn the ignition key, and the car will start. I'm not really worried about how the things will happen under the hood. So this is how the car manufacturer has given you an essential feature. He has given you the car keys, he has given that ignition point where you turn the key on, and that's what is essential to you. You don't have to know anything else. So that's how abstraction, one of the another pillars or another concept of object-oriented programming is based upon. The classes and objects does that. It just exposes that those essential features that you need. So for example, if I go back to the car example, this object Anne doesn't need to know what are the this characteristics of this. If object Anne just wants to start the car, he'll send a message to the start method over here. It doesn't need to know what are the characteristics or what other methods are there. It's not bothered about that. The object just knows I have to pass a message to start, and that will act on this object and car certain variables. But what variables and how it will do it, it doesn't do. So it exposes this object and exposes this essential feature, the start method, to object and. That's it. There is no need of going into the details of what is start method is doing, how it is starting the car. We don't need to know. So that's how abstraction is obtained. Okay, and certain things have gone wrong. Anyway, so encapsulation is another pillar, is another concept based on which object-oriented principle is or programming is done. So what is encapsulation? It's the mechanism by which we combine data and the functions that manipulate the data. So in an object, if you have an object, then its data or the characteristics or the attributes, for example in the car example, I saw color, I saw model, I saw type. So these were the data, and we had the methods. We had the start method, we had the reverse method. So this data and behavior is together. You cannot really separate the data and the behaviors of a class and do something. So when you create an object from a class, and in a class you will have characteristics of this data and the behaviors. So when the class is instantiated or object is created, then these two things will be together in the memory allocation. You really can't separate the data from the behaviors. So this is encapsulation. It encapsulates the data and the behavior together. Okay, so that's how encapsulation is obtained or attained in object-oriented programming. Now we go into the next. So in the shipping box example, as we saw, if we have in the real world a shipping box, then what would be the extraction or what would be the essential features that we need? We will need the sender's name, the receiver's name, cost of shipping per pound, weight. These are kind of the important characteristics or important data that you need for calculating or modeling the shipping box into the digital world. So we have this abstraction, we have this behavior, calculate shipping cost. So this is the abstraction. When a user wants to use this application, he just knows that I have to give the sender's name, receiver's name, cost of shipping per pound and weight, and when I say calculate, it will calculate the shipping cost for me. He really doesn't have to know what is this variable doing. So this is the abstraction of the shipping box, and from this abstraction we have the class as we saw earlier. So we have the sender name again, receiver name, cost per pound, weight, and the shipping cost method actually. So this method will act upon these two variables and give you back the result. So this is abstraction. We have the certain features, certain essential features that are needed to model the real world object to a digital world. Okay. Okay. Now we had seen inheritance. Now this is the inheritance example which I had shown diagrammatically earlier. So I have this parent account, the bank account. It will have some characteristics, some behaviors. Now those are inherited by the child. So though it's not shown over here, this checking account, when an object is created, will have the parent class data variables also, or the data members. So this will be data members from parent. This behaviors also will come. So we will have the behaviors over here, the data over here. So we'll have the behaviors over here. And in addition, since this is a checking account, it will add its own characteristic, its own behavior. So from the parent class, we are inheriting. We don't have to write this again in the child class, all these things, but we can add our own specific features, our own specific methods. Similarly with the savings account, we will have the parent, this characteristics and behavior copied into the object. When we are creating the savings account object, since it is inherited from bank account, it will automatically, these things will automatically get copied into the savings account object. Okay. So this is the inheritance example. So what is inheritance? It is actually creating new classes or derived classes from existing classes, or base or parent. In Java, actually we call a parent class as base class, and a child class is called a derived class. So it is creating new classes from existing base classes. Now the derived class inherits the variables and functions of the base class and adds additional ones. So we saw it in the previous example where the banking account, the variables like customer name, account type, everything was inherited by this checking account, is inherited by this savings account. You are not going to write it again. You don't have to write it again, because since this is a child of bank account, it will automatically get this variables and behaviors. So that's what it says. The derived class inherits the variables and functions of the base class and adds additional ones. And it provides the ability to reuse existing code. So for example, this deposit method, whatever code you had written for deposit method in the bank account or in the base class, that you don't have to write again for this checking account. When you call the deposit method, it will automatically execute the parent class's deposit, unless of course we'll go into that details later if in the checking account the deposit process is slightly different. So that will go into details but later. But this deposit method as such, you don't have to write again. So we are reusing the code in the child class. Okay, so we have covered this. Now we come to another very important concept of object-oriented programming, that is polymorphism. Now what is polymorphism? Polymorphism is the concept of one entity showing multiple behaviors. That means if I have a single method, say add, in a calculator, now this add method will behave differently for different types of data that is coming into it. So if I have to have, want to add two integers, now addition of integers and decimal numbers is slightly different, specifically when you are doing the multiplication and division kind of a thing. So for simplicity, I am taking the addition method. So when I have two integers, I'll add it one way, and when I am trying to add decimal numbers, I'll have to add the integer portion and the decimal portion. So there's a slight difference over there. Now this add method could be one. In a Java program, this could be a one single method, and depending on whether this data that you are passing to the method is integer or float. So we'll come to know this data types later. So float is a decimal type of variable, decimal type of data type, and integer is another integer type of data type. So this add method will behave differently depending on these two parameters that you are passing. And so what is, again, if you see, polymorphism is the ability for a message or data to be processed in no more than one form. In more than one form. This no shouldn't be there. So we are passing data to this method, and depending on this data, the data is processed in more than one form. So example, if we consider a real world example, Spider-Man as Peter Parker, when he goes to the school and sees a friend, his behavior is as Peter Parker. He is a friend of that person. But if he meets his enemy, so he changes to Spider-Man and starts fighting that enemy. So he is the same person, Peter Parker, but in a school when he sees his friend, he is behaving in one way, and when he sees his enemy, he changes his behavior into Spider-Man and starts fighting that person. So that's how polymorphism, the same person but behaving in different way. The same method but different, behaving in different way depending on the parameters or the arguments that are passed into the method. So that's polymorphism. So here is another example of polymorphism. Suppose we have a shape object or a shape class. I'll consider this as a shape object. We have created an object called shape. Now, shapes could be of different types: circle, triangle, square, rectangle. So if I have a circle object, this is another object, circle, and this could be another object, say triangle. Okay. Now the circle calculation of circle area will be different from calculating the area of a triangle. Now this shape object has the method area, and these two are actually inherited. So from the shape object we are inheriting circle and triangle, but this area will be different. Calculating this area will be different than the triangle. So when a shape or a circle object calls its area, it has to pass the radius. So it will have an additional characteristic or additional variable called radius in its class. So when I am creating the object, that radius will be there. When I am trying to create the area, it will actually multiply. So area of a circle is pi into r square. So this area will actually calculate this pi into r square depending on the variables that we pass, or depending on the object that we have. This triangle will calculate the area in a different way, height, half height, base into height maybe. So this area will behave in a different way. So though method is same, depending on the objects, depending on the child objects or the shapes, this area will be different. This area will behave in different ways. So that's another example of polymorphism. Okay. Now we have seen all this while what is OOP, why use OOP. Mainly we have seen the advantages of OOP. Now there are certain disadvantages also, because no programming language can have 100% foolproof way of solving problems. So in OOP, the initial extra effort needed in accurately modeling the classes and subclasses for a problem is more. So when you are trying to first design the classes and the subclasses from the real world, when you are trying to solve a problem from the real world, the initial extra effort will be needed. So that's where you might lose, or you might you might lose on the application front, because certain programming languages like C will behave little differently. You don't have to give so much effort, you just have to write the procedures. But over here you have to design the classes, you have to really actually find out how to map the real world to the digital world. And it's suitable for modeling certain real world problems as opposed to some others. So we cannot solve all the problems in the real world using object-oriented programming. We have to use some other paradigms or some other methods to solve the problems. So those are the disadvantages of object-oriented programming. This is the conclusion or a wrap-up what we learned today. We have learned what are classes and objects. we have learned the concepts in object-oriented programming. So these four are the pillars, or the concept, the actual concept which is there in object-oriented programming, without which, if one of these are missing, we cannot say that programming language is object-oriented. So these are four essential concepts that has to be there in every object-oriented programming: abstraction, encapsulation, inheritance, polymorphism. So these are the concepts that are very important, and we saw the advantages and disadvantages of object-oriented programming. So that's it from my side. Thank you.